Hey guys, in this tutorial I will be discussing two more problems on differentiability. So in this question we have to check the differentiability of this function at all real numbers. So first let's consider any real number, say k, which belongs to R. So let's find the differentiability of this k. So f dash of k is equal to f of x plus h minus f of x by h, which is equal to f of x plus, we replace x for x plus h, uh, x plus h whole square minus 4x plus h minus x square minus 4x by h is equal to, when we expand this we get x square plus h square plus 2xh minus 4x minus 4h minus x square plus 4x divided by h. X square get cancelled, 4x get cancelled, that's it. We get h square plus 2xh minus 4h by h. This is equal to, let's divide h. Oh, I forgot the limit here. H tends to 0, h tends to 0, yeah. So let's divide the h throughout. We get limit h tends to 0, h plus 2x minus 4. So when h tends to 0 we get 2x minus 4. So at k we get f dash of k, which is equal to 2k minus 4. Since this is a finite quantity and n exists, therefore the function is differentiable. Basically all polynomial functions are differentiable. In this question, they've given a function modulus of cos pi by x and we have to check the differentiability at x equal to 2. So first let's find the left derivative at 2. So limit h tends to 0, f of 2 minus h minus f of 2 by minus h. So let's replace this and put in the function. We get modulus of cos pi by 2 minus h minus modulus of cos pi by 2 by minus h. So cos pi by 2 is 0, so this term becomes 0. Limit h tends to 0, modulus of cos pi by 2 minus h by minus h, which is equal to, here when we put 0 we get the numerator as cos pi by 2, which is 0, and the denominator is h, which is also 0. So 0 by 0 we can use the L'Hospital rule. Therefore limit h tends to 0. Differentiation of this is minus sine pi by 2 minus h by minus 1, and using chain rule we also get pi into minus 1 by 2 minus h whole square into minus 1, because differentiation of 2 minus h is minus 1. This get cancelled. This is limit h tends to 0. When we get minus of minus is plus, so sine pi by 2 minus h into pi by 2 minus h whole square. So when we substitute h equal to 0 we get sine pi by 2, which is 1. 1 into pi by 2 minus 0 is 2, so 2 square is 4. So 1 into pi by 4, that is pi by 4. Then we have the right hand derivative at 2. So limit h tends to 0, f of 2 plus h minus f of 2 by h. And here, while removing the mod, we also get another minus, because when we subtract a number h from the denominator, the this value lies in the second quadrant, which means that this value cos in the second quadrant is negative, so we have to add an extra negative here. So we get another minus, and therefore this minus pi by 4. And continuing with the right hand derivative, we get this. Replacing, we get limit h tends to 0 modulus of cos pi by 2 plus h minus cos pi by 2 by h. In this case, since we are adding h to the denominator of the angle lies in the first quadrant, and therefore cos at the first quadrant is positive, so it remains positive. So when we remove the modulus, we get limit h tends to 0 cos pi by 2 plus h. Cos pi by 2 is 0 by h. 0 by 0 form, L hospital, we get limit h tends to 0 minus sine pi by 2 plus h into minus pi by 2 plus h whole square by 1. So this, when we substitute the value, we get sine pi by 2 is 1, and 2 plus 0 is 2, 2 square is 4, so this becomes pi by 4. So if you see, we get minus pi by 4 on the left side and pi by 4 on the right side, so the function is not differentiable at x equal to 2.